6. Okay, question 6 works like this. Okay, question 6. Let's read the question. Question 6 is equation of the tangent to the curve y equals to 3x squared minus 2x plus 5, which is perpendicular to the line 4y plus x equals to 2. Okay, perpendicular to a line 4y plus x equals to 2. So first I write down perpendicular to 4y plus x is equals to 2. So first what I do here is I get 4y equals to negative x plus 2, y equals to negative 1/4 x plus 2. So you notice this negative 1/4 x, this tells me that the gradient of the line, okay, is negative 1/4. However, we want to find the perpendicular to this line. So what I do is negative 1/4 times m is equals to negative 1. So the gradient of the line that I'm trying to find, okay, is m equals to 4. Then they say find the equation of the tangent to the curve, which is perpendicular to the line. So now I start with my curve. I say that y is equals to 3x squared minus 2x plus 5. Okay, so basically, right, I'm trying to say, alright, where is it, right, on this curve, okay, where the gradient is equals to 4. So first I say, I do my first differential, 6x minus 2 is my first differential. I already know that the gradient that I want is 4. So I equate this, I say that 6x minus 2 is equals to 4. Why I do this is because I need to find a corresponding x value, okay. I know the gradient is 4, but I have no x value, no y value. So what I need to do is I equate the gradient to 4, okay, then I solve for x. Okay, 6x is equals to 6, x is equals to 1. And remember, in order for me to find the equation of the tangent, I'll need a y value. So where do I sub this x value in to find my y value? Is I sub into the original equation. So I substitute x equals to 1 into y equals to 3x squared minus 2x plus 5. My y value is 3 times 1 squared minus 2 times 1 plus 5. And I find that my y value is 6. Now I got a x value, a y value, and I also know the gradient already. So all that is left to find is the y-intercept. So I start and say y is equals to 4x plus c. Okay, so I substitute x equals to 1, y equals to 6. 6 is equals to 4 times 1 plus c. I find that my c value is equals to 2. So therefore, I will state that the equation of the tangent that I'm trying to find down here is y is equals to 4x plus 2. And that is done for question 6. And the final one that I want to show you for this topic is, or this subtopic rather, is question 16. Okay, question 16 works like this. Find the gradient of the tangent to the curve at the point 1, 2. This one slightly, we have x cubed plus xy squared is equals to 5. Okay, in order for me to actually even be able to start to find the gradient of the tangent, alright, what I need to do is this, I need to differentiate. But in order for me to be able to differentiate, I must have the y as my subject. So I start with xy squared equals to 5 minus x cubed. So y squared is equals to 5 over x minus x squared. I divide throughout by x. Okay, and finally y equals to 5 over x minus x squared to the power of half. Y to the power of half because I square rooted both sides of my equation. Then I start to find my dy dx. I do half 5 over x minus x squared to the power of negative half. Okay, don't forget that this is chain rule, so I have to differentiate inside my brackets as well. So I differentiate this, I get minus 5 over x squared minus 2x. And if you want to simplify everything, I get 1 over 2 square root of 5 over x minus x squared times negative 5 over x squared minus 2x. Okay, don't bother simplifying this any further already, because what we need to do now is I want to find the gradient of the tangent, and I already know the x value at the point where I want to find the gradient, so I let x equals to 1. So I get 1 over 2 square root of 5 over 1 minus 1 square. Okay, I just let x equals to 1. Okay, multiply to minus 5 over 1 square minus 2 times 1. So I get is 1 over 2. 5 minus 1 is square root of 4. Square root of 4 is 2 times negative 5 minus 2. Then what I get is simply negative 7 over 4. And this is the value of my gradient at the tangent point 1, 2. And I'm done with question 16.